Okay, section 1.5 is whole numbers, exponents, and powers of 10. The vocabulary for this section is base, and the base is going to be the bottom number here. The exponent, or the power, as it sometimes it will call, the value is going to be your answer. Squared is a new term, and that means to the second. Okay, that would be the 2, and cubed is to the third. Okay, when they're doing exponents and powers of 10, basically an exponent then, if I'm going to multiply 3 times 3 times 3, I can write that in the shortcut version of 3 to the third. The 3 tells us that we have 3 numbers being multiplied together. So 3 times 3 is 9 times 3, then I would have a value of 27. Okay, so the 3, or the exponent, tells you how many of the numbers we have. Another example over here, I have 10 times 10 times 10 times 10, or 10 to the fourth, because I have 4 tens multiplied together. A lot of times you may see it written in this form. It's another way to do the same thing. When you have parentheses around a number next to each other, it is an operations. This is an operation symbol. Multiplication, division, addition, subtraction are all operations. So 10 times 10 times 10 times 10, it's the same thing, 10 to the fourth. Okay, so you're simply counting up how many of the numbers you're multiplying together, and they have to be the same number. Hence the base. The base is that same number, and the exponent tells you how many of them there are that's multiplied together. So once you get it in this form, they're asking you then in the next section to put it back. So this is 5 squared, which means 5 times 5, which equals 25. 3 to the third, as we demonstrated here, would be 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. If I had 2 to the fifth, I have 5 2's. Don't fall in the trap of doing 2 times 5 and saying it's 10. This tells you the 5, or to the fifth power, tells you have 5 2's. So 2 times 2 times 2 times 2 times 2. Okay? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Anything to the first power is always going to be itself. And it says I have 1/15. And then a little fun fact to know and tell that's not in the book, but I always like to throw it in to classes, is anything to the 0th power is always going to be 1. Doesn't matter what it is. If I had 1,000 to the 0th power, it's still going to be 1. Okay? Next section is talking about multiplying numbers by powers of 10. So a couple of ways to write this out is that, I'm going to drop this down here for just a second. I can have 88 times 10 times 10, which equals 100. So really I have 88 times 100. So you can cover up here with my finger. I have 1 times 88 gives me 88. And then I have those 2 zeros. I add those back in at the end. So basically 100 times 88 is 8800. But another way to think of it is kind of that finger trick where I have 1 times 88, and then I count the number of zeros and put that in the answer. So up here we have 1 times 29. So get my finger out of the way a little bit there. 1 times 29 gives me 29. And I have 3 zeros, because this is going to be 10 times 10 times 10, which is 1,000 that has 3 zeros. You notice the correlation between the exponent and the number of zeros we have. So 1 times 29 is 29. We have 3 zeros in the answer, or in the problem, and therefore we have to have 3 zeros in the answer. So 29 times 1,000 is obviously 29,000, but that's kind of a shortcut way to think of it. Over here, when you get to problem number 37, we're now doing division. We were multiplying a minute ago, now we're dividing. When we multiply, numbers get bigger. When we divide, they get smaller. So we can rewrite this problem then as 528,000. We're dividing by 1,000 because 10 times 10 times 10 gives us the 1,000, 3 zeros. And then we can simply reduce. 0 on the top can reduce with 0 on the bottom. So how many thousands is 528,000? Well, 528. So that's kind of that shortcut method for dividing by a power of 10. Just simply it cancels out the number of zeros. So the same thing down here. I'm going to rewrite the problem. Divided by 10 to the 5th. Okay, so that means I have 5 zeros. 5 is the exponent. 5 zeros is my answer. Okay, and again, I can simply reduce those. 1 0 on the top reduces with 1 0 on the bottom. It just cancels out. Alright, and so now I have how many ones in 4,500, which gives us 4,500. Have fun with the homework.